All right, what we have here is a classic example of the kind of equation in algebra that gives people fits. In fact, a lot of people just avoid even trying something like this because of the fractions involved, and they just assume, well, if it's fractions, this is going to be tough for me to do. Now, there's a way around it that works every time there's an equal sign. So this is the key. If you can find anything you're solving and make sure it has an equal sign, that means it's an actual equation, you can use a property to your advantage. And that property is this. If you can change one side by the same amount as the other side, you haven't changed what they mean. Okay? The whole thing has the same meaning as long as we do the same operation to both sides. Now here's how this affects fractions. Basically, I would like these fractions to go away. I would rather work with whole numbers any day. And this isn't the only way to deal with fractions, but in my experience, this is the easiest. If you just want the fractions to go away, but you don't want to change what this thing means, you'd still like to be able to solve it correctly, then what we need to do is we need to find a number that we can multiply by that makes these fractions go away. Here's how it's done. We need to find the denominator of every fraction involved. And what we need to do is find a number that both of these will divide into. Okay? We need to find what's called the least common denominator. And in fact, we don't even have to find the least one. We just need any number that 4 and 3 are both factors of. And sometimes the easiest way to figure that out is to just multiply these numbers together and use that value. So that's what we're going to do here. Now I'm going to try to erase this so we don't get ourselves too confused. We are going to use the number 12 because 12 is a value that 3 and 4 will both go into. And what I'm going to do is I'm going to draw parentheses around both sides, and I'm going to multiply this side by 12 and this side by 12. Now I know the first thing most people look at is they say, oh, 12 times 2 divided by 3, it gets a little complicated with the fraction. So let me show you how to set this up. Let's look at this part right here first. Okay, that would be 12 over 1, that's what this is, times 1 over 4 times x. And if we just multiply straight across, this is going to give us 12 fourths x, which is really just 3x. That 3x looks a lot better than this up here. I'm going to erase this just because my handwriting is a little poor, and make sure we can read that. 3x is way better than 1/4 in terms of the ease of dealing with it. Now, the consequence of this is we can't just do it to the x terms, we need to do it to everything. So I need to multiply 12 by this also. It gets multiplied to everything. So 12 times 8, that gives me a big number, 96. But don't assume there's anything wrong with that. It's just a bigger number. Okay? Now on the other side, right here, first let's deal with this stuff right there in the same way we did before. 12 over 1 times 2 over 3 times x. That gives me 24 thirds x, which is just 8x. Much better to deal with. And then on the other part of that, we have 12 times 10, which is 120. Okay. Now, at this point, we have something here to work with that is way easier than we had before. They're big numbers, but at least they're whole numbers. So our goal now is to get all the x terms on one side and all the numbers on the other. And you can pick whichever one you want. I think I would probably subtract 3x because I always like dealing with positive numbers on my variable when it's available, when I can. Okay, that leaves me with 96 on this side and 5x minus 120 on that side. And then I'm probably going to take the 120 and add it. Okay. And when I add 120 to 96, I'm going to get 6. Oh, I better erase that. I'm going to get 6. 9 plus 2 is 11. So I get 216 equals 5x. Now what you notice is it doesn't look like this problem's going to come out nicely, but that's okay. It doesn't have to be a whole number. My last step, divide by 5, divide by 5. And a lot of times people are uncomfortable doing this, but you don't need to be. X equals 216 fifths. Now we could divide those and get a decimal. We could change it to a mixed number. There's a lot of ways to write it, but it's okay to just leave it like that as well. Okay, and that's how you account for fractions in any equation. If there's an equal sign, you find a number that you can multiply both sides by that will make those fractions go away. And it always has to do with the denominator.